1 second here.
Welcome and thank you for joining us today for Kubernetes at Scale, Challenges, Priorities, Adoption Patterns, and Solutions. My name is Raleigh Gould and I'll be moderating today's event. Our featured speaker is Torsten Volk, Managing Research Director at EMA. With over 16 years of enterprise IT experience, Torsten helps end users and vendors leverage the opportunities presented by today's hybrid cloud and software-defined infrastructure environments in combination with advanced machine learning. While Torsten will defer answering your questions, we do encourage you to log them anytime by using the Q&A functionality. Also, today's event is being recorded and you will receive a follow-up email from EMA with the on-demand playback, as well as some additional resources. So I hope you'll check that email out. And now I'd like to go ahead and turn things over to our featured speaker, Torsten Volk. Torsten?
Hello, everybody, and welcome to our webinar. Also, a big thank you to our sponsors, VMware and SUSE. SUSE, yeah. And this research is really all about Kubernetes in real life, in the real world. And how do I harness Kubernetes to get my job done as a developer, but also as an operations guy or as a security guy. And when I say real world, let me just advance this deck here. Raleigh, why this deck does not advance? Raleigh, can you help me with this deck, please? Oh, now it advances. I don't know why it took that long. Okay, cool. So I want to start with the key takeaways for this study. And yeah, then everybody can leave and basically know everything that we talked about. But in reality, when you have a study that goes that deep into the different personas in the market, like developers, platform engineers, SREs, security engineers, it makes really sense to take a look, really almost like a retrospective. What did we learn from this study? And this slide or this text is right at the end of the study document. So when you read it, those are the conclusions that you see at the end. And I just want to go through those really briefly, and then I want to show you how the study arrived at those conclusions, and most importantly, show a few interesting data points and demonstrate what's going on in Kubernetes from the different perspectives today. So in terms of key takeaways, number one, and that's really also the number one most important one from my perspective, is that developers need to spend less time learning, implementing, debugging infrastructure topics, things that are not related to developing business software, because that's what they like to do, that's what they get paid for. And if they worry about Kubernetes, if they worry about infrastructure, about anything that's underlying, even if it's infrastructure as code, that sounds like coding and programming, but really it's just a different way of defining and creating infrastructure. So those are all things that are side projects for developers that make them less productive. And that's what we want to minimize as much as possible, and in terms of helping enterprises reduce their pain when it comes to Kubernetes. Number two, the platform engineers want to be able to deploy and scale and run applications without requiring much help from the development team, right? Because that's another big pain point, that platform engineers are not able to support the applications, to move the applications, to deploy another instance, to scale them without code changes and without really understanding what's going on inside of those applications. And that is something that is a problem. Ideally, the platform engineers should be able to do this in a containerized application that's based on microservices. Hand in hand with that goes the policy-driven unified automation and management, of the deployment, management, and operations. Everything to be scalable and to be consistent, it has to be policy driven. And by that, I mean that we go based on our business requirements, we build those policies, and then we roll out our stuff, our applications, the infrastructure that they need. And we roll that out across the entire organization, and not just in a specific Kubernetes cluster or for a specific application, but we roll that out across all of our clusters, across all of our clouds, and the data center and the edge and everywhere else too. And yeah, that's basically hand in hand with the next point. Public cloud managed Kubernetes clusters are seen as the answer, often by individual development teams, and they are fantastic. They are great, and they have 50% market share right now, simply because they're so easy to spin up and to consume. But the problem is there is so much stuff around those managed Kubernetes. So we call it cloud managed Kubernetes, and really what's cloud managed is only the scheduler and orchestrator for Kubernetes, but Kubernetes is so much more. It integrates with network, with storage, with compute, with a lot of individual cloud services, security services, compliance, all different things. And those are not part of the managed Kubernetes, and those are things that we need to take care of in a more automated and policy-driven manner. Enterprises adopt multiple Kubernetes distributions. Yeah, that's a lesson that we learned in the study. We had a hunch already when we look at a lot of DevOps teams that are making Kubernetes cluster generation part of the DevOps pipeline. So whenever I spin up a test, or I create a new environment, or I do anything in terms of experimentation, often we spin up more Kubernetes clusters, and we end up with a whole bunch of them, even for an individual team. And then we spread those around across different clouds and different locations. And we just need something on top of all of that to harness that for our business without cost escalation, without compliance issues, without security issues. And yeah, that's what point 6 is. A unified Kubernetes management platform is critical. That just means that managed Kubernetes on Amazon, on Azure, on Google Cloud is fantastic, but you still need something that reins in the complexity of those deployments, that makes them consistent with your company goals, your company policy, what you're basically trying to do. And that then also allows developers to be productive, because they can deploy the same code to different clouds and different Kubernetes clusters if they're all configured in the same way. If they're not, you may run into all kinds of issues that you may or may not have already run into. And yeah, 7 is here, point 7, we split 50-50 between public and private cloud Kubernetes. That's basically an adoption metric right now that we found out in that study. I'll show you a slide to that in a moment. And then finally, the Kubernetes special interest groups. And that's nothing nefarious. Special interest group is simply when you look at GitHub, you see the individual groups that Kubernetes sponsors or members are part of, and they take care of individual aspects of Kubernetes, and the API, storage interfaces, security, and observability are the most active and the most, yeah, I mean, important is a big word, but let's just say it for what it is. The most is going on in there in terms of issues submitted, in terms of code commits, in terms of discussions going on, and that shows us the important pieces today. So moving on. So now I'm going to just give you a few slides and a few extracts from that research that backs up with facts what I just said on that summary slide. So if you want to leave now, that's perfectly fine. You've heard basically the all of the meat of the study, but now I'll show you a little bit of the cool stuff in terms of how we created all of this. So what we want to do is here we want to get from the actual day of a developer to the ideal day of a developer. And you see the ideal day includes a lot of writing code, even though writing is misspelled on this slide for some reason. Writing new app code. And but what they do in reality is what you see up here. They deal with infrastructure, they deal with security and compliance, they deal with deployment and management of apps, they configure visibility, observability, they worry about cost, they worry about how to deploy and manage stuff on public clouds and on different public clouds. So it's all things that are not directly contributing to their value generation. And keeping that in mind, we see the overall Kubernetes stack here and the complexity of that Kubernetes stack, where Kubernetes itself is only a small part of it. And that explains and connects back to what I said in the beginning, where if managed Kubernetes is fantastic, but if I only manage or get managed by a public cloud, what is in that red circle, then there's still all of that other stuff around here that is not managed and that I need to configure and that I need to make accessible to my developers and my platform engineers so that they can deploy it, run it, scale it, manage it, change it, update it. And that's where the actual problems start. And coming to this next slide is very interesting. You can see there is literally, and that number was even surprising to me when I ran the various queries. You may know that all Python libraries, or I mean, there's a main repository on the web for Python libraries, and that's the PyPy repository, where you can basically find them all. So every time you install a new Python library, your IDE pulls it from there, unless it's something more niche and you have to pull it from GitHub or from somewhere else. But 1,609 of those libraries are Kubernetes related libraries. So that is a crazy number, I think, and it shows how far we have, as an industry, embraced Kubernetes. And I ran another quick query where I categorized all of those libraries, and you can see that here we have the biggest chunk here is for software developers, and that's basically stuff that helps you be more efficient developing your software. So that's deploying or running code on Kubernetes and accessing the individual parts of Kubernetes so that your software can scale better, so that your software can work the way you want it to work in an easy way, integrated in your development environment. Then the next big one is systems. So systems is all of the stuff that Kubernetes runs on. That can be EC2 interface, that can be for Azure, can be for MongoDB database, or anything that's a system underneath Kubernetes that you still want to control and address from within a Kubernetes application. We see over 200 systems libraries in Python there. And obviously, I'm only talking about Python. It's very similar in Java. If you look there, there's similar statistics for Java. That's why we are just focusing on Python, just to keep that simple. Then science and engineering libraries, internet connectivity and networking libraries, security, database, specifically multimedia. And that goes into really vertical use cases, like how do you run a database on a Kubernetes cluster? How do you run video decoding or encoding and multimedia workloads on a Kubernetes cluster? How do you host emails there? So all of those things together show you that people are doing a lot of stuff on Kubernetes. There's a lot of use cases by now on Kubernetes, and we have a couple more charts showing that real quick. And this is just you may know that website called Shodan, where you can basically get raw data from port scans of anything that's on the internet. So basically what this did here is it just scanned all of the, it just listed the total number of all of the machines that had Kubernetes on it, because if they're publicly available, you can read out their header, the HTML header and HTTP header, and you can see that they are Kubernetes, that they belong to a Kubernetes cluster. And we can see the number went up like this here. And yes, it didn't rise that much here from 2021 to 2022. That's a matter of, I believe, the search engine ramping up their capabilities. But if we start looking at it from 2022, we see the quite rapid increase. And roughly back of the envelope calculation is we have 1.3 million clusters here, and it's roughly a little bit more than half of the total clusters of Kubernetes worldwide that we believe can be scanned publicly. And that doesn't mean that they are vulnerable or have any access to it. It just means that they ping back on the internet if you do a port scan. And just to show this a little bit here, that we did a quick analysis of the CNCF Slack for Kubernetes. And why did we do that? Just so that we see, with that rapid adoption also came a lot more challenges and a lot more discussions, in this case on Slack, about Kubernetes. And, how do I use Kubernetes in real life? How do I solve Kubernetes problems? So this went up between, as you see, 2020 and 2021, as I so nicely jotted on there in red pen or pencil, 66% increase from 39,000 to 65,000. And that's just the first quarter. That's simply because the data was collected in the first quarter. We have updated that by now. It's still the old thing here on the stack, but it gives us the same trajectory compared to, if we had done the second quarter this year, the percentages would not have changed. That's why we just left the first one. This is a slide, and I'm just going to forward on across that very quickly. It's something that's interesting. If you do a Google search for Kubernetes, what are the most likely other Google search terms that you are searching for? And obviously, we can't know the persona here. So this is literally just for anybody who searches on Google, and this is based on Google Trends API data. So we just see, those are the most connected terms and topics together with Kubernetes, Docker, Kubernetes pod, AWS, Helm, Ingress, Cluster, Azure. So not all that surprising. Maybe I wanted to see Google Cloud somewhere here in that list, but yeah, it's not there. A couple more Kubernetes facts. I'm going to go through those also quite quickly. You can take a look at them, and also later when you get the deck, you can look at them in a little more detail. You can basically see what I said before. The public cloud managed Kubernetes holds about a 50% market share compared to free open source distributions. So those are basically, any Kubernetes distribution that you install yourself. Then commercial distributions, those are commercially supported distributions basically. And pure upstream Kubernetes is the Kubernetes that you just download upstream from GitHub, and you do it yourself. You roll it yourself. Which Kubernetes distributions are you currently using? Amazon EKS is by far the number one here, and this was a question amongst DevOps engineers, 2,100 DevOps engineers we asked. So that's what that is. That's it shows the tendency of Amazon EKS being the most popular place to host Kubernetes, and then coming Azure Kubernetes Service and Google Kubernetes Engine. Then for the hybrid Kubernetes is the SUSE Rancher Kubernetes Service and the Red Hat OpenShift and Tanzu Kubernetes Service. Then the most popular operating system, Debian/Ubuntu and Fedora/Red Hat Enterprise Linux. So this is just, I know a lot of people are interested in those stats. That's why I thought I put those into this deck. And if you want to go much deeper, then, read the actual study. There's tons and tons of much deeper market data in there too. So what I mentioned before was the Kubernetes distributions. And at the time of the study, or when we published that study a few weeks back, or a month and a half back, then we found that there is 140 something, I think 142 or so, different Kubernetes distributions and installers that you can get, and that you can use. And just wanted to bring out that number because that leads to another finding, and that is that we see a lot of companies adopting different Kubernetes distributions, not just one, but 2, 3, 4, 5. There's a chart in the research document as well that shows a bit of an overview of how many different distributions companies often adopt. And there's still often that mentality where, oh yeah, we'll go with that specific application that has that and that compliance requirement, or that has that and that support requirement, so we are using XYZ Kubernetes distribution, a specific one that is different from what we're using in the rest of the company. And similar is what we see here, the public cloud Kubernetes universe. We see that, if we are like an Amazon Web Services fan in our team, then we use that AWS universe. We use a lot of S3 storage. We use all of those services that go around AWS that we like. Here you see it at the bottom too. There's EKS specific, another quadrant that's focused on EKS specific. And just so that you understand what this is from, how we got this data and what determined those squares, because you wouldn't know that without some explanation. This is simply Stack Overflow data. So it is based on Stack Overflow tags, meaning that if a topic was mainly about AWS in general, it went into this block up here that's all about Amazon Web Services. If the topic was specific to EKS, so to EC2 Kubernetes service, then it went into this quadrant. And the size of the individual squares is all the number of views that they received on Stack Overflow over the last 12 months. So that's proportional. Exactly how many views they are, it doesn't say here, but that's also not relevant, because what this gives us is it shows us the more important topics versus the less important topics. So you can draw some conclusions from there. And the interesting thing is, if I go for Azure, here we have Azure and here we have Azure AKS, then I will use different monitoring, different storage, different CI/CD than if I go for Google Kubernetes Engine on Google Cloud Platform, or if I go for AWS. It will just be a different universe that I'm in, and I will use in most cases, their Kubernetes distribution, which is, different between the individual clouds. And what makes that then complex is all of the other stuff that integrates with Kubernetes that is there in the environment. And this goes really hand in hand with the meat of the research, right? This is probably from a research perspective, the most important slide, together with a sister slide where it gives the same numbers for IT operators. And there's another sister slide that tells those same numbers for security engineers. But if I look for challenges for application developers, here are the challenges from top to bottom that are the most important. And funnily enough, AWS, AKS, GKE is at the top of the challenges. And the way we calculated this is we simply looked at all of the different sources that we have, like Slack channels supporting Kubernetes, Stack Overflow, Stack Overflow questions on Kubernetes by developers, and a whole bunch of other sources with really a lot of data points and a lot of issues recorded. We went basically through those sources and found all the ones that are specifically related to these topics. And AWS AKS GKE came out at the top in terms of Kubernetes related challenges for developers, which is interesting because those are managed Kubernetes services, but they are still part of the most questions and challenges compared to all of the other problems. Number two, we have network, and service mesh obviously is a big part of that. How do I connect individual services together as a developer? That appears a lot and wastes a lot of developer time. And number three is deployment. Number four, security, storage, configuration, observability, API. And this is a simple chart here, but in reality, obviously, security is often part of AWS AKS GKE. Or of networking, or of the deployment, or deployment is part of AWS. So there is overlap between those. And yeah, that overlap you do not see in this specific chart. But as a general guideline, AWS AKS GKE, network, deployment, security, storage, configuration, those are the key challenges. And if we look at that from the operator perspective, we see that network, public cloud, security are the most important challenges for IT operators. So the operators, and we count platform engineers obviously to the operators. And those are all the things that are the lower level tasks or the lower level networking tasks, so that developers can actually consume the service mesh and use the service mesh to connect their microservices applications. It's a big part of those networking issues, public cloud issues, where we want to optimize the cost of the public cloud and the degree of utilization and efficiency in general. It's a big challenge. And so interestingly enough, public cloud is also here very close to the top. And yeah, this is a very interesting slide that I really wanted to put into this deck, and I'm going to also only skim over this, so feel free to really dig into that later. But human mistakes are a big thing when you have such complexity, and when you have such a stack that consists of different technologies and different tooling, and then you combine many of those stacks, because every microservice has one of those complete stacks, and they are different, or they can all be different, then every mistake or every inconsistency that you do, you may come to regret at a later point. And we collected here a whole bunch of interesting examples of those issues where you do something unintentionally or even intentionally, and you are not aware what horrible consequences this may cause. So that's why we connect back to what I said initially, that we need unified management and a unified way of observing what's going on in our environments. And hand in hand again with that goes the number of Kubernetes vulnerabilities, doubling between 21 and 22. And in general, there's a significant trend that show toward more Kubernetes vulnerabilities. As you can see here, I've broken that down a little bit. Top chart shows by product, and the bottom chart shows by topic area. So you can see the orange piece here is number one, that's API related security vulnerabilities. Then the green one is authentication and authorization. Then the brown one is code injection issues. Then the purple one is patches applied too late. So yeah, those are all the different types of challenges. And you can see there's a big variety of different challenges here. And that variety is reflected in this chart that gives you a quick overview from the perspective of the operators on Kubernetes complexity. So this is simply an automatically generated chart that picks up automatically we used some basic transformers for machine learning, and categorized the data sets that we had. And those were the categories that came out, all of the areas that customers are having or that users are having issues. So yeah, so from a higher level perspective, the Kubernetes management platform here, it consists of different overall modules, and those modules again are needed so that I can harness or govern or control Kubernetes, so that I don't run into those security issues that you saw in the previous, or so that I'm not susceptible to those, or less susceptible. Not is always a wrong statement in security, but I want to be less susceptible to those security issues. And to get into that position, I need a Kubernetes management platform. And generically, that is the overall topology of a Kubernetes management platform. Those are the individual parts that that platform has to cover. At the top, all the application things, connecting the application to itself, so to other microservices, to its data, and managing the actual code base underneath the Kubernetes cluster itself. I need to manage, and at the bottom, the infrastructure that it runs on, the different clouds or server hardware or whatever it may run on, I need to manage. And yeah, that's it. Just a few last words, a quick summary here. And yeah, I highlighted the important parts in yellow for you to easier see right away. The key lessons are Kubernetes clusters per enterprise are increasing quickly. It is not like what we thought maybe initially, that we do extreme multi-tenancy on individual clusters. The fact is much more that clusters are prolific and they pop up and they get terminated and they get moved, and customers combine different distributions, different teams use different distributions, and we need to make sure that we control and govern that from the enterprise perspective. And developers need to be able to focus on writing code. Today, they're spending too much time, roughly half of their time, on things that are not writing code. And, that's when we give away productivity and also motivation of developers. They don't specifically like writing YAML infrastructure code or dealing with cloud API differences between AWS and Azure, or doing all of those tedious things that are basically just things that you can look up somewhere and you have to get a template and implement them and make them work so that your application scales and works on different clouds and all of that. So yeah, and that separation between platform engineers and developers is critical. They need to be able to communicate and collaborate, but they need to be able to do their jobs separately so that both of those groups can be productive. The platform engineers can be there to basically provide the developers with what they need and run it and upgrade it and scale it. And the developers, they basically just provide the code and deploy that code independently of the infrastructure that it is running on. So policy-driven and unified automation and management is what we need to pull all of that off. We need to be able to have the same policy applied to a application that runs on Kubernetes on AWS versus VMware versus on Rancher or anywhere else. It should not matter what cluster it is. The corporate security policies and guidelines and best practices should always be controlled, implemented, and then also be able to audit it. So I want to be able to pull a report that gives me a single view on all of that. And if I have any drift in configuration, especially security relevant or compliance relevant or performance or cost relevant, then I want to see that across accounts and across clouds and across my entire enterprise. And I don't want to have to go between teams and check this for every team individually. And yeah, at the bottom, EKS, AKS, GKE are great, and they really changed the game, but we have to all remember they are a means to an end for public clouds. And what I mean by that is they enable people to quickly onboard applications to, in the easiest possible way. And then once I have those applications on each of those respective clouds, that's when it gets interesting to those cloud providers, because that's when I start spending money, the real money, on all of those other services. And that includes observability, like logging and metrics can become very, very expensive if you are not governing it and configuring it properly on those clouds. That's why FinOps is such a big discipline right now and such a big topic today. And those were the lessons, again, tying back to what I said in the beginning. And yeah, if you have any questions, hit me up on Twitter, or I suppose shoot me an email. That's it from my end, Raleigh. Do we have any questions? Anything else today we can address?
Thank you, Torsten. Yes, let's take a couple questions before we conclude. The first one is, are VMs on Kubernetes a real thing? Are companies using them?
Yes, they are becoming more and more of a real thing. Also from a migration perspective, where you just want to run everything in a consistent environment, and you just want to manage VMs in a similar manner that you manage Kubernetes containers, and you want to apply the same policies to it. And people are looking to manage all of this in one environment. It is definitely a trend that we are seeing. I don't exactly know what the market share is, and how many VMs are part of Kubernetes clusters, but it is definitely a real thing.
Good to know. Thank you. Let's take one more question before we wrap up. It is, what's going to be the next big bottleneck once we've overcome the ones listed in your study?
So there's new workloads. I think we get a lot of questions about large language networks and AI in general, and running inference workloads and training workloads on Kubernetes. And Kubernetes is absolutely perfect for a lot of those use cases, but it also, the title of the study was scale, using Kubernetes at scale, right? And that is the real deal test if somebody's Kubernetes is scalable, if you can actually really use it for this kind of thing without being very inefficient. And if you're very inefficient in this area and running those large language models or other large AI models, then you have significant problems with the cost, because resource allocation will be so unfavorable, and you will have to over provision and run your workloads basically on separate infrastructure without sharing all that much. You'll run into real serious cost consideration, and also possibly performance issues, and also compliance issues. So all belongs together, and the reason why this becomes more interesting is that if you talk about microservices applications, they are, or at least they're supposed to be, relatively small. Every microservice is supposed to be relatively small, but AI workloads are big, chunky things that, they're large. They have a lot of data connected to them. It's much more, requires much more planning to spawn them and to move them and to keep them all safe and compliant and cost efficient. That was my long answer to a short question.
Great. Thank you, Torsten. And thank you, audience, for joining us today. As I mentioned, you will be receiving a follow-up email from EMA with additional resources on this topic, so be sure to check that email out. Thank you again for joining us, and I hope we'll see you at a future EMA research webinar.
Thank you.